Hi everyone. I wanted to do just a quick follow-up on yesterday's lesson on probability distributions. So this is an example. This is not in your notes. Actually, I took this out of the textbook. If I had assigned you the homework from the textbook yesterday, this would have been one of your problems. So I'm going to work through this one with you. You can follow along. If you want to write it down, you're welcome to. So we're looking at a lottery here, and we're selling 125 tickets, okay? And we're giving away one first prize, one second prize, one third prize, and everybody else loses, okay? And so we want to create a probability distribution. Whoops. So our random variable here, or our x, is the cost of playing, or what, I guess we should say what you can win from playing. But we have to remember to take out the cost of buying the ticket. So if you are, let's see, I'll do this here. There's my table. If you play the lotto and you don't win, essentially that's a -1 in your bank account, right? Because you paid the dollar for the ticket and you got 0 winnings out of it. Okay, so that's one possibility. All right, and that's a pretty high possibility. If you win third prize, okay, you win $20, but you paid a dollar for the ticket. So technically you won $19, okay, because of the $1 you paid. The $30 ticket would actually be a winning of $29. And if you win first prize, that would actually be winnings of $49. Okay, I made my table a little too large there. So now what I want to know is, what is the probability of each of these outcomes? Well, it says that I'm only giving out one of each of these, and there's 125 tickets. So each of these would be like 1 out of 125, and 1 out of 125, and 1 out of 125. So then we need to ask ourselves, what's the probability that this happens? Okay, and remember, this is you lose. This is you don't win anything. Okay, if there are 3 winners here, that means there's 122 people that don't win. So that's 122 out of 125. Okay, and again, just to point out, because this is the really big emphasis with probability distributions, if I were to add these all back up, this would be a total of 1. Okay, probability distributions always add up to 1. Okay, so this is the part we didn't get to yesterday, the expected value of the ticket. The expected value of the ticket is basically a weighted average, okay? So it's like we're saying we have one of these and one of these and one of these and 122 of these, all right? So I'm going to take each one of these variables and multiply by their probabilities, okay? And then add them together to get my mean. By the way, expected value, that's the same question as if I were to ask you for the mean value here, okay? The mean value of a ticket. So this is what I'm doing. I'm going to do -1 times 122 out of 125, okay, plus 19 times 1 out of 125, plus 29, 1 out of 125, and 49 times 1 out of 125. And so what this is telling me is, in general, on average, what do I expect to happen here? Okay, what kind of value do I expect to get from this ticket? Sorry, I'm scrounging for a calculator. It's early in the morning here. Okay, so I'm going to type this in. I'm going to do -1 times 22 over 125 plus 19 times 1 over 125 plus 29 times 1 over 125 plus 49 times 1 over 125. Okay, and I get an expected value of -0.2. So that means on average, I'm expecting to lose 20 cents here. Okay, that's a 20-cent loss. Chances are I'm not breaking even here, right? I'm much more likely to fall in this category than any one of these. But when I average in the value of these ones, this would be my mean value of all my tickets if I were to add together everybody's ticket and total them up. Just to save you some typing here, by the way, I did it just the way I wrote it because that's what I said I was going to do. But I do want to point out that since these are all out of 125, the other way you could have typed this in is like this. We could have done -1 times 122 plus 19. Well, that would really be times 1. Okay, obviously we don't really need to put the times 1. Plus, what was my other one? 29 times 1 plus 49 times 1. Okay, and that's all fine and good. Remember that you still need to divide that by the 125, but you can just do that all at once at the end if you want to. Okay, so just an easier way to type that calculation in, but really that's what expected value is when you take each value, okay, of x and multiply it by its probability and then add those all together. And what that's really telling you is, on average, what do you expect to happen? Okay, so I want to go back to, this is your notes from yesterday. So if you haven't been taking notes, that's fine, but go ahead and get your notes out now. Okay, if you need to pause the video, that's fine. I'm going to quick throw this back here. Our probability distribution for this problem, this was talking about the numbers of boys in the family. And remember we said we could have 0 boys, 1 boy, 2 boys, or 3 boys. Man, I cannot judge the size of these tables today. And then my probability here was 1 out of 8, 3 out of 8, 3 out of 8, and 1 out of 8. This is the example we ended with yesterday. So now I'm going down to this expected value thing. I would do 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. Okay, so I took each one of these values, multiplied by the probability, added them together. Okay, when I'm typing this in, I'm going to kind of use my shortcut here, and I don't know that I really need to type the 0, but I will just for argument's sake. So 0 times 1 plus 1 times 3 plus 2 times 3 plus 3 times 1. And then remember, I'm going to take that whole thing at the end and divide by 8. Okay, and I get 1.5. And so what this means is that on average, a family of 3 children, we would expect to have 1.5 boys. Okay? Now, obviously, you can't really have 1.5 boys, but that's why you'll hear, like in population data, they'll talk about, the average family has 2.4 children or something along those lines. Comes from something like this, okay, and an expected value. And that should make sense, right? Because this one was just a 50-50 chance. I mean, boy, girl. So in a family of 3, we would expect half of them to be boys, okay? But that's expected value, that's mean value, however the question's worded, that's the calculation you want to do. Okay, so for today, you have a quiz review to work on. And the last page of the quiz review, I believe, might not be the last page, but somewhere in there, there's a lesson master on this lesson 7-6, okay? So now you should be able to do everything on that lesson master, and then I will take questions on that when I see you tomorrow.